Well, we're ready to tackle another subject. This is the second in a series of 6 instructional videos on effective operation and maintenance of separate and combined sanitary sewer collection systems. What's so amazing to people is the number of jobs you have, all of them vitally important. In this tape, we take a close look at your job as a television inspection system operator. I guess you could say we want to show you how to be a TV star.
All right, people, all right, work with me here. Everybody settle, and action.
As always, we can depend on Gonzo to illustrate how not to do it. Volume 1 and Volume 2 of Operation and Maintenance of Wastewater Collection Systems are the source manuals for these training videos. The information on where you can order these manuals and the other videos in this series is also printed on the cover of this video. By the way, from time to time on the screen, you'll see a number like this. It refers to the chapter and section in the manual where you'll find more information on that subject. Now you're going to become TV stars by learning how to operate one of the most effective tools for inspection, the miniature closed-circuit TV camera and monitor. In this video, we'll use 2 different cameras. One is pulled by a winch. The other is driven by a tractor crawler. Your equipment may be slightly different, but the principles are the same.
TV inspection overcomes the guesswork and estimates of the past, when many thousands of dollars were wasted on unnecessary pipeline cleaning, rodding, and needless excavation and sewer replacement work.
The closed-circuit TV inspection system is an accurate and reliable way of recording the problems and solutions to our pipeline system.
Answers to what, where, how bad, and how much in a way that has never been possible before.
TV cameras can be used to inspect sewers anywhere from 4 inches in diameter all the way to 48 inches in diameter. In other words, sewers that are too small or too dangerous for a man to enter, we can use the camera.
Here are some of the pipe and joint problems that closed-circuit television can inspect. TV inspection can search for unrecorded connections that may be illegal residential or industrial taps and unrecorded connections that could be letting groundwater or surface drainage enter the sewer.
TV inspection combined with dye test can be used to pinpoint inflow sources and estimate the volume of inflow also. The dye and the TV can also pinpoint exactly which tap the inflow is coming from.
TV inspection can be used to determine the type and exact location of any damage caused by excavation and construction on nearby utilities, paving activity, and building construction. And it can also be used to locate buried or lost manholes. A similar application is inspection of newly installed or recently repaired pipes and taps made by contractors during construction.
TV inspection is also a great tool for evaluating maintenance solutions. Before we ever open a manhole lid, first of all, we have to test the atmosphere to make sure there's no explosive conditions existing in the manhole. If you receive an alarm while you're testing the atmosphere, you do not open the manhole lid. As long as there's no alarm, you're safe to open the lid. They're now placing the rip cord over the manhole. This is what we use to string the line with. After he gets there, he will start the parachute through the line. Well, you string the line in order to get the cable through the main line to pull the camera through. Having trouble getting the chute in the line, so Randy's using the pole to get the chute started.
Okay, Greg, it's running, isn't it?
Yeah, it is.
10-4, it's not taking it.
Well, is there a hydrant nearby that we can run water to it?
We're trying to do everything possible to keep anybody from having to enter the manhole in order to get the line strung. The parachute isn't working with the ripcord. Is there water anywhere, Randy, where we can string the line with water?
Yes, there is.
Okay, let's go ahead and string the line with using water then. Randy's hooking the hose up to the air gap. You use the air gap so that sewage cannot be brought up back into the fresh water supply system. Greg is now removing the ripcord from the manhole and is placing the balling pole into the manhole in order to catch the parachute when it gets here.
Okay, I'm set up and ready. Go ahead and let it in. Okay, hold and shoot.
Greg's going to set up the downhole gear now, put the cable in the shoe so that it won't rub against the pipe and create a groove in the pipe.
You can go ahead and power back the cable though.
Okay, the cables arrived. We're now ready to set up our TV equipment and to begin TVing the line. Greg is now going to clean the lens so we'll have a good picture while we're televising the line. Now we're going to put on a defogger. Okay, Greg is now hooking the downstream cable to the front end of the camera so that we can pull the camera down the line. It's hooking up the TV cable to the back of the camera now. He is adjusting the slack adjuster. That's very important because if it isn't adjusted properly, the power supply will come unplugged as you're TVing the line. For added protection, Greg is taping the connection to the power supply in hopes that it won't come unplugged as we're televising the line. We're ready to lower the camera now. Randy's going back to the control room and powering up the camera to check it before we lower it into the manhole. Okay, Greg is now going to lower the camera into the manhole. Randy's going to take up slack, pull the camera into the line a few feet.
Go ahead and take it to 8.
Take the camera to 8 feet. Greg's taking up slack so we can get an accurate measurement on the camera as it goes down the line. And Greg is now setting the outside footage counter.
Okay, you're set.
The old cameras had tubes that were light sensitive. However, the new cameras have chips in them and the sunlight is no longer a concern while we're setting up the equipment. We're in the control room of the TV van right now. That's the monitor, VCR down below the monitor, controller for the camera. Randy has the hard copy, which he's just finished filling out.
And what I've done is just I've stopped to identify a number 1 rooted joint with a very slight offset within the mainline segment.
With a drop joint like this, pulling the camera past will cause it to drop and will prevent it from being pulled back. In the case of a jump joint, the camera must be jumped from right to left to pass. A drop joint looks like this. As you can see, a jump joint is slightly different. Pulling the camera past offset joints like these can prevent the camera from being retrieved the way it went in.
Or if your camera gets trapped, you might try what I try. Come out of there, you're trapped. We have you surrounded. There's no way out. Now, doesn't always work.
Accurate footage is a vital part of the TV inspection. If the parcel map book shows a line of 250 feet, but we came out with 260 foot on our footage counter on the TV, we would go out and physically measure the line. If we find that our footage counter on the TV is inaccurate, then we'll have to have it recalibrated. After the footage counter is recalibrated, we will re-TV the line. Okay, as you can see, as Randy goes along to make a notation, he puts the recorder on pause so that whoever reviews this tape won't have to sit through a long tape. It shortens the tape quite a bit. While Randy's making note on this particular route, this route was probably quite a bit larger during our original stoppage. The line has been cleaned with a flailer on a hydro machine in order for us to TV it without running into too many problems.
26.7 feet, we have number 1 rooted joint. At 80.6 feet, we have a tap on the left.
A similar application is inspection of newly installed or recently repaired pipes and taps made by contractors during construction.
TV inspection is also a great tool for evaluating maintenance solutions.
TV inspection revealed the need to make this repair. It's a protruding tap from a home service line, a source of infiltration and root intrusion. After digging to it, the crew found an old hammer tap, which they'll replace.
When we come out to green tag the job, they'll come out and they'll do a TV inspection from the clean out to the main. And that's how they find out if it's a hammer tap and if the tap's any good or not.
Your equipment may be slightly different than ours, perhaps made by a different manufacturer, but the operation is basically the same regardless of the equipment you're using. And of course, staffing requirements may also be different. And even though this video is not on safety, there are a lot of videos out there on that subject, we want to remind you to always make safety your first concern. Now, here's the foreman.
We need 3 crew members and equipment similar to this to complete this operation. What we have here is 2 tractor-driven cameras. The first one being our large camera, which can do pipe size from 8-inch to 108-inch. The second one being the smaller unit, which can do pipe size from 6-inch to 24-inch. Today, we're going to use the small unit to go from this manhole downstream in the right-of-way to that approximately where that telephone pole is located. This is a good example where it would be hard to utilize a winch in this right-of-way. So we will be using the small camera to go downstream, and it will retract under its own power. The equipment we're going to use for closed-circuit television inspection consists of a special television camera, camera lights, power cable reel, and a video unit, TV monitor, system power control, portable power source, in this case an onboard generator, and either a camera pulling winch or a tractor crawler.
Other equipment often includes a sound-powered telephone communication system.
Okay, testing. Is this thing on? Okay, you guys will love this one. A chicken, a goat, and a weasel walk into a bar.
Before inserting the camera, the sewer lines should be cleaned.
The purpose for cleaning a line ahead of time is to remove sludge, grit, grease, and roots that could interfere with the operation of the TV camera. The first step in this operation is to raise our lifting device. It's a crane, and it's lowered. The crane is set up to lower the camera tractor unit itself into the manhole. Okay, first we set the camera on the ground before we open the manhole cover. At this time, we'll also clean the lens. Okay, take her up. Kick this guy down in there and hang on to the rope. Once the camera is aligned into the manhole itself, it can be driven off the lifting device. Okay, now we're ready to install our down rollers and other rollers to guide the coaxial cable as it feeds out of the drum. We're attaching the down roller sheave to protect the coaxial cable as it's fed off the cable drum. A device that'll hold the cable roller up onto the crown of the pipe. We install another roller in order to make a smooth transition from the cable drum through the manhole to the camera. Now we'll take up the slack. Go, get it. And we're basically set up now.
By moving the camera downstream, any debris in the pipe should be washed away in front of the camera, and any buildup on the back of the camera should be removed as the camera travels along.
The camera should usually be driven with the flow. However, with a tractor-driven system, you can drive it upstream against the flow. Of course, in a new line, you can go upstream regardless of the equipment you're using. This unit is computer controlled. The tractor, the monitor, and the cable drum are all computer linked. At this time, we enter our footage, all pertinent data, our depth of our manhole, and anything else you might think of. We go through a setup menu. Be sure to record the direction in which the camera is traveling along with distances. After our cable count preset has been entered into the computer, we also need to enter the depth of the manhole. By doing that, I just push a button. The menu will appear. It's asking me the depth. I punch in the depth, and it'll confirm on screen. Our last entry, it needs to know the wheel size of the tractor itself. I push the appropriate button. I enter the wheel size. Again, it'll confirm on screen the wheel size. We've now completed the basic setup and we're ready to inspect the line.
Some video monitor stations have keyboards with sewer defects noted on the keys. This facilitates uniform identification of problems encountered in the TV inspection.
At the center of the screen, you'll see a footage count. That's how far the camera has traveled down the main from where the camera itself was inserted into the manhole.
Now let's turn our attention to some special precautions that are related to certain types of conditions you'll encounter.
As the operator of the camera, it's your responsibility to be aware of any hazards to the camera-tractor combination. Should the bottom of the pipe be missing and the camera rolls into it, there's a pretty good chance that the unit itself will have to be dug up by a repair crew.
When the operator can see by the monitor that the camera is going underwater, the crew will need to make the necessary adjustment.
If the camera ever does go underwater, when it comes out, there's a good chance it'll have a film or scum on the lens. Try backing the camera up back underwater. This may wash off the lens and you'll be able to continue your inspection.
Moving the camera rapidly backwards then forwards to create a wave may wash the surface debris away.
Another trick to clear a fogged or greasy lens would be flushing with clean water from either a fire hydrant, a tanker truck, or even try a garden hose.
Another remedy, if the distance is short enough and there's no stoppage, you can pull the camera to the downstream hole, clear the lens, and pull it back to where you left off.
Off-center vertical tumbling with this particular operation should not be a problem because on screen is a horizontal stabilizer indicator. Winch-driven camera systems should also not experience a problem with vertical tumbling, as they should be self-righting if they're properly designed.
If a camera doesn't right itself in a few feet, it's an indication that something's wrong. The operator should select the safest and most rapid method of getting the camera out of the line to determine the cause of the problem.
The next camera problem is a foggy lens. Like glasses will fog up when you go from a cold exterior to a warm interior. In the same way, from cold to hot, the camera lens will fog up.
Remember, glass that is warmer than the atmosphere will not fog.
An anti-fog compound sprayed on the lens may be effective, but I just warm up the camera by setting it inside the truck. Should the camera lens fog while in the main itself, just stop and wait. Chances are it'll clear.
Don't allow grease to accumulate on the light head. If the heat from the light ignites the grease, the light head could be damaged beyond repair.
Yeah, that's a good boy. And you don't want to let grease get on your eyes because then you'll stink and no one will want to play with you. Okay? That's a good boy. Yeah, she's a good boy. You want to rub your tummy? Yeah, rub the tummy. Ah, he's a good boy.
The standard light used on a sewer inspection television camera is an encased halogen lamp. These lamps, similar to a projection lamp, reach extremely high temperatures. The lamp and its reflector must be permitted to cool to a safe level before anyone handles the camera. Be aware of the fact that the heat from the light head of the camera could ignite certain explosive gas mixtures. Therefore, it is important that gas detection equipment be used prior to allowing manhole access to employees or equipment. Remember, do not operate a TV camera in any line that tests positive for explosive gases.
If the sewer is flowing so full that the camera will be submerged while inspecting, plug off at the upstream manhole and TV as soon as the water drops.
Be careful that the wastewater held behind the plug does not back up into someone's home or flow out of the top of the manhole.
Don't touch the cable with bare hands or even leather gloves. Small pieces of wire you can't see can pierce your skin and cause serious infection.
The correct way to handle sewer cable is not to handle it. That's the job of the winch and pulleys. Whenever you're in doubt about anything, look it up in the manual or ask your supervisor.
Okay, that'll be your first point, Tim. We'll mark there. This is a locating device in which we use to locate when there's a problem with the main. When we need to dig it up and make any repairs, we use this. There's a ferret sending device 3 feet back from the front of the camera lens. It sends off a signal that's picked up with our receiver here, and we're able to pinpoint and mark it exactly where we need to dig.
Now let's look at the procedure for shutting down and removing the camera.
Okay, we're approaching the downstream manhole. We'll ease on up into the boot. Stopping just when the snaps start to roll up. Release the pressure on the cable, turning off the power to the camera. Okay, Mike, camera's there.
The TV operator stops the camera or gives the command to stop. At this point, the inspection is completed.
Now we'll go down and see the removal. As we mentioned in the trailer, we disconnected the power. He's doing it. We released the tension on the power winch. So now we take the power winch out of the way, take the hook off the pole, and then we use the shoe to pry the camera out of the line. Shoe comes out. The camera is in the manhole. Then just pull the camera up. You unplug the camera from the coax, which also serves as a tag line. Toss the coax back into the manhole, and you tell the operator that the coax is clear so we can roll up the cable. If this would have been a tractor-driven camera, we would pull it back to the trailer with the reel, with the tracks going in reverse to save wear and tear on the rubber on the tracks themselves. And the tow cable would be the coax itself because it's steel reinforced. If for some reason the camera was stuck and we couldn't pull it back upstream due to an offset or some other obstruction there, we would need to go down into the manhole with all the proper safety gear. A hard hat, safety harness, safety rope, ladder, gas detector, goggles, rubber gloves, anything that the situation would demand. Every situation is different. Making sure that the power is off before you pull the camera forward. There's no electricity going to it. Then you safely go down there, pull the camera into the manhole, disconnect, and pull it up. If you think while cleaning this that a petroleum-based product is on the camera, you want to use a proper cleanser. Make sure, though, doing that you keep it away from the seals and do not use gasoline because gasoline will also ignite if the lenses on the light head are still hot. Afterwards, what we do, we'll clean it with water and maybe a citrus cleaner, and then we'll take it back to our yard and steam clean the camera. If you were to notice petroleum-based products in the sewer line or that are on the camera, you would want to record them and call your supervisor because it would be something that shouldn't be in the sewer line.
Finally, on the cleaning process, tetrachloride or chlorethane chemicals should be avoided. They're hazards to your health and can destroy seals and coatings on the camera. After the inspection report has been completed, the TV equipment is removed from the manhole and prepared for the next section to be televised.
Jake, you got it. Come on out.
With the camera retrieved from the manhole, the crew will replace the manhole cover carefully. Next, the camera and equipment is cleaned.
This concludes the second tape in this training series designed to supplement these two operator training manuals. Following is information on how to order these manuals and training tapes. We'll see you next time. Say goodbye, Gonzo.
Oh, goodbye, Gonzo.